In the name of God, hi guys, my name is Alireza.Rashiddel. I am so happy I am here and I can teach the FLAC2D 3D free training course to the geotechnical, mining, civil and geological engineers. I graduated from 𝐬𝐨𝐬𝐿 University in the tunnel and underground spaces engineering in 2016. Right now, I am a geotechnical and mining engineering researcher in Portugal. The session 1 of our training course is about interaction of faulted zone with a underground mine tunnel. We want to simulate our case with FLAC2D 8 and FLAC2D 9 versions. Here you can see the geometry of numerical model, hanging wall, footwall, interfaces between hanging wall and footwall, crash and faulted zone, length of model, height of model, thickness of faulted zone, and degree of faulted zone to the surface, ground surface. In this slide, you can see some usual structure in underground mine tunnels: bolts with the shot grid, steel arc with the shot grid, and steel arc with meshing. I want to explain the rock bolts and cable bolts in the field of tunnel engineering to know a different procedure of these bolts. Here you can see a rock bolt, a mechanical rock bolt with expansion shell approach. Here you can see expansion shell. Another mechanical rock bolt is a slot wedge rock bolt, wedge and slot. Second type of rock bolts are grouted rock bolts. Here you can see resin grouted rock bolts with 2 cartridges. And cement grouted rock bolts. Here you can see cement grout and rebar. My goal is previous explanation of rock bolt is know about differences of cable bolts with rock bolts. As you know, the cable bolts include some strands, some steel strand. Here you can see grouted cable bolt with cable and cement grout. Also here you can see strands of cable bolt. We want to model different support scenarios in the crash zone, interaction of crash zone with the tunnel. First one will be unsupported scenario. Second, just steel arc. Third one is shot grid. Fourth one is cable bolt, and number 5 is cable bolt, combination of steel arc. Number 6 is shot grid, combination of cable bolt, and number 7 is shot grid and steel arc. Number 8 is shot grid, cable bolt, and steel arc. Of course, we can model this combination, number 8, just with the FLAC2D version 8. In the FLAC2D version 9, we cannot model a steel arc. Here you can see the properties of joint and rock mass properties, and joint properties, interface, fault interface. Here you can see the properties of crash zone or faulted zone and properties of structure. Here steel arc structure with MPI profile, shot grid parameters and rock bolt parameters with diameter 25 millimeters and length of 4 meters and distance between cable bolts 1 meter. We will model cable bolts, not rock bolts. But in the FLAC2D8, we want to model arc steel arc with the parameter of shape factor. With this parameter, we can assign the equivalent cross section for a steel arc in the linear structural element. Okay, let me to go FLAC2D 8.1 and create the geometry of numerical model, and after that we go to the FLAC2D 9.1 and we start the geometry of numerical model. Okay, we have here some options. We don't need these options, and also we don't need advanced constitutive model. We don't need include safety factor. Just we need include structural elements. Okay. Select the location of project. Mine tunnel. Title false. We don't need right title. Okay. You can see the name of project here, mine tunnel. We can create geometry in the FLAC2D8 with the different tools and different approach. We can create the simple geometry in the FLAC8 with coding, usual coding of FLAC8 with 𝐼𝐸, and also we can create geometry with use of icons, grid, sketch, and these options and virtual meshing. Because in this model I have a joint interface and faulted zone, we need to have an interface between crash zone and footwall and hanging wall. For this reason, we must to create the geometry with a sketch and virtual meshing, virtual option. If we want to create the geometry with the usual codings, we cannot, maybe we cannot create the internal boundary of joint interface. Okay, let's go to the sketch. In the sketch, I select the box. We put the positions of 2 points, minus 100, y-min is minus 20, y-max is 30. Okay, press copy. Okay, we go to the builder tools, builder tabs, and create the geometry of filtered zone. We select the line and input the points of line, start point and end point. 27.5, 30, minus 32.1, minus 20. Okay. Second interface, 32.1, 30, minus 27, 5, minus 20. Okay. We check the blocking of geometry. We have 3 blocks, 3 4 sides block, 1, 2, 3. Press build. Okay. We have here automatically initial mesh. We go to the edit tools and mesh zooming option, and we select extra fine mesh. Okay, good. This meshing is good for our project, for our case. And we go to the boundary and select my mark boundary and select these 2 lines to create marks of filtered zone. Also select set interface here and here and set properties. We have here glued interface. The normal stiffness and the normal shear stiffness of glued interface assigned with the equivalent stiffness. You can search equivalent stiffness in the manual of interface formulation, and usually we select the 10 times equivalent stiffness or 100 times equivalent stiffness. Okay. Blocks, material. Okay, we don't need to assign material here. Okay. Execute. We can save with the name of geometry. Geometry. Okay. We have a save file of geometry here. Interface. Mark. And internal boundary. We can magnify the internal boundary. Okay, you can see internal boundary here. It's okay. Let me to go FLAC9 and start the creation of geometry. Okay. New project. Okay. And location of project. E9. Mine tunnel. Okay, nice. Save. From select content, we select sketch set. the name of a sketch mesh, geometry or mesh, geo and mesh. It's good. And we call the DXF file of tunnels. It's good. Here we have geometry of tunnel. In the FLAC2D9, we need to create the geometry of tunnel in the first geometry, but in the FLAC2D8, we don't need to create the geometry of tunnel in the first geometry. Let's draw the geometry of box. We select corner to corner box. Okay. You can see here the position of points. Here. Also here you can see the number of geometry. Again, we select corner to corner and draw the box of tunnel, box of numerical model. Here you can see the value of point. Okay, good. We select the line. '27 position. Here you can see 27, 27.5. It's okay. And minus 32. Okay. .32 .1. It's okay. 27.5. So here in the section of tunnel, we don't have edging. In other lines, we have edgings. You can see the edging of lines. And so, we go to the set default edge parameters and number of zoom per edge. We write 1, okay. And automatically aging. Here you can see the aging of tunnel geometry. It's okay. We go to the set meshing parameters. We don't need to create another settings. In auto size, the length of zone will be 1 meters. Okay, we have here the length of edge in the other lines. You can see. Okay, and mesh all polygons. We have meshing of geometry here, and we have some bad zooms, and here, here, and here, and here. We can edit this zoom. Okay. 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 Again, we press mesh all polygons. Okay, everything is good. In this geometry, we have different shapes of geometry of meshes. For example, here we can see the triangle mesh geometry, and here we can see the quadrilateral of mesh geometry. Okay, we press right zoom, Okay, good. Meshing up our model is ready in the FLAC 9, and we go to the FLAC 8 and continue the modeling. Edit, and we go to the in situ X, fix off X velocity in the lateral boundary, fix off X and Y components in the bottom of boundary. So execute. We can go to the initial tabs and select all, zoom, stress, SYY. Press assign, minus 1350 E3 kilopascal. This is kilo. Variation in X component is 0. In Y direction, variation is this value. Okay. Here you can see arrow direction. Sum of this value will be the surface of model SYY, and in the bottom of model we have SYY stress with this value. Minus is mean the compressive stress. Okay. Assign K0 or lateral earth pressure or in situ stress ratio. I don't need to assign the lateral earth pressure ratio. If you want to create the lateral earth pressure, you can write SYY, and you can write the K0, and you will have automatically 𝐜𝐨𝐧𝐭𝐞 and 𝐜𝐴𝑥. Cancel. Okay. Material. Assign. We create material of rock mass. We create material of crash zone. Create. Name rock mass. With the more column criteria, in the elastic perfectly plastic behavior. Mass density is 27,000. Elastic modulus is 10 gigapascal, 10 E9. Poisson ratio is 0.27. Cohesion is 0.8 megapascal. Tension is 1.8 megapascal. Friction angle 25 and dilation angle 10. Okay. Create the properties of crash zone or faulted zone. With the same criteria. (0.1 gigapascal), Poisson ratio 0.32, cohesion is 10 kilopascal, tension is 0, friction angle 29, and dilation angle is same. Okay. Select region and select rack mass, press here, and file zone, press left click here. Here you can see the groups of geometry, rack mass group and faulted zone group. Three region with two groups. Okay, here we have geometry and meshing constitute model with material properties and boundary conditions and gravity of Earth. Okay, go to the Run tab and choose the solve initial equilibrium as elastic model. As you can see, we cannot reach the equal ratio 1e-3 because there is some faults here, some mistakes. We cancel. In the solid elastic stage, we have to create the geometry of Earth without geometry of faulted zone. So we delete the geometry of faulted zone and select rack mass and this region. Press. Okay. Let's go to the Run tab, solve equilibrium as elastic model. Okay, good. Save. And let's go to the sum, checking up plots. Check the plot of Y displacement. Y displacement is good. Here we have minus 2.5 millimeters. In this region we have approximately 0 vertical displacement. Also we can check the total stress. It's good. Okay. Okay, we continue and we go to the next SIV and we follow. Here I want to activate the properties of fault zone. Okay, we have group of fault zone here, and we must to activate the interface of fault zone. Interface of fault zone between hanging wall and footwall. We save fault zone and we go to the initial stage, then copy the codes of interface and rebuild again. Okay, good. Fault zone, edit, paste the codes and delete this code. Interface 1, glute, we write unglued. We assign the rail values of stiffness, normal stiffness and shear stiffness. 18, E9, and 20. We write the values of another parameters because we have unglued interface. Cohesion is 0, dilation is 8 degrees, friction is 20, tensile strength is 1 megapascal, 1E6, and SB ratio is 100 default, and B sleep on. Okay, rebuild. Oh, bad number, we have bad number here. Okay. This code, this parameter will be tension bond, T bond. T bond. Alright. It's okay. We have here interfaces. Okay. Save and follow another SAV. We import the XF of tunnel geometry. Okay. And we use utility tabs and tools table, create number of table, and draw the geometry. Okay. Edit. We close the geometry. Execute. Go to the Alter tabs, Shape, Utility, Shape Tools, Table, ID, Generate, and select a point and edit of the machine.com. It's good. Execute. Okay. We go to the Material tabs, Assign Tool. Select the node and region. Oh, it's not. We have a problem here. execute and go to the alter shape point. It's okay. It's good. Material assign. Also, we have a problem here. Okay, cancel, alter shape, point. Okay. Okay, execute. We created the geometry of tunnel. It's okay. And we solve up the model and to have a unsupported scenario. Stop and write set large, because we will have large formations, and it is better to write set large approach. For a good result. For bad geometry, we have here bad geometry. We go to the CV, rebuild, alter shape, okay. Solve. Here you can see the vertical displacement value is 2.5 minus 1. We have bad geometry. Here. Again, solve. Here you can see large deformation of faulted zone to the inside of tunnel. Finally, you can see the collapse of tunnel in unsupported scenario. Here. Okay. Save. Unsupported scenario results. You can see the collapse of tunnel, large deformation of faulted zone, and large deformation of crown of tunnel. But there is a mistake here. It is better to edit that. It's good. Okay. Run. Refresh. Okay. Save. With the name of unsupported or tunnel. We create some clone here to create another scenario with cable board, unsupported. Before assigning and applying a cable bolt in the ground of tunnel, we go to the FLAC2D version 9, and here we select here and here assign rack group. Also we select the inside of tunnel, group name tunnel. Focus zoom. Okay. Assign constitutive model, more column. Okay. Density. Young modulus. Percent. Okay. Go to the assign group name to the face. Ignore exciting group names. Okay. Automatically we have here the waist, east and top face and bottom face. You can see. It's okay. Save the model. Okay. And create a DAT file. Initial. Okay. Model new. We write the codes of the initial state. Model new. Model restore. The name of SAV. Mesh. And apply boundary condition. Zoom. Face apply. Velocity. It's also we can use another code about applying the boundary conditions. Zoom fixed grid point, another code. But I select zoom face apply. 0, range, lateral boundaries, group, rest, and this. Copy these codes below. Zoom face, apply velocity 0 and 0 in two directions, X and Y, range group, just button. Okay, rebuild. It's good. We check the boundary conditions. Okay, add plot. GP fixity is okay. Fixity of X and Y there, Y in the bottom, and fixity of this grid point in the X direction. Okay. Model gravity, (9.81), and model largest ring up, model solve last. Model save initial. Okay, rebuild. Okay, we can check the plots and outputs. Zoom, reactive, contour, displacement, Y. This is okay. Select stress, Y. It's okay. Okay. We create another PAT file. We can have fault of zoom. Same this. Okay. We want to implement the first scenario. Zoom, delete. No. First we must write model new, model restore, the name of SAV, initial, zoom, delete inside of tunnel, range, group, tunnel, and rebuild. Okay, we have the okay, we can check the excavation. It's okay. Back to the faulted zone DLT, and zoom property, zoom C model, assign configure model and property to the crash zoom, C model, assign we press Control space from keyboard and insert more column. Zoom C model, configure model, assign more column, range, group, crash zoom, the fault zoom. Copy, zoom property, bulk, we go to the here, okay. Bulk, shear, cohesion, friction, dilation, tension is okay for faulted zoom. Ready? Okay. In this stage, we must to activate the interface of fault and face off between the hanging wall and crash zone and face off footwall between footwall up and crash zone. Zone, face, group, interface 1, internal, range group, 𝐸𝐸 and crash zone. Faulted zone. Zone separate, by face, new site, group, the name of face, new face 1, range, group, interface 1. Here we created the face of interface in this code, and in the block code we separate the faces of interface. zoom interface 1, the ID of interface, create by face. With this code, we want to create the interface, the real interface between rack and crush zone, between hanging wall, foot wall, and crush zone. By face, range group, new face. Okay, the property of interface, we assign the property of interface, zoom interface 1, node property, delete this code, and node property, press Control space on keyboard, interface property, and insert the parameters. Friction, cohesion, bounded slip, tension, shear stiffness, normal stiffness, shear bound ratio. Okay, friction is 29. Also we have dilation 29. Oh, excuse me, friction is 20. These properties are for interface, and so friction is 20 degrees, dilation is 8 degrees, cohesion is 0, tension 1E6, stiffness normal stiffness is 18E9, two E9 shear stiffness. Cohesion dilation, bounded shear bound ratio 100, bounded slip on. Okay, we have problem here. Okay, range group rack, and group halted. Okay, repeat. Bad conversion of parameter number, new slide. Okay, we have a typo here. Slide. Okay, rebuild again. We press Ctrl space and check the codes. Zoom separate by face. New slide. New site. This is new site. Okay. another group space here a bit. Okay, we can check the plots. Deactivate zoom displacement and add interface. Okay, also add boundary. Okay, here we have interface. Model largest strain on, because we predict maybe have larger strain and large deformations. Okay, model solve, model save, the name of unsupported scenario. And rebuild. And check the plot of displacement. Here we have this large deformations and the collapse of tunnel. The result of unsupported scenario for FLAC 9 and FLAC 8 is same. As you can see here, we will have large deformation and movement of crash zone inside of tunnel, to inside of tunnel. Yeah. Like FLAC2D 9. Okay, good. In the next stage, we will activate structure elements and table elements, and we will investigate the combination of structures and other support system.